Okay, let's look at this function with sine and cosine equal to 0. It's very easy to solve it. If I just bring one function across and divide both sides by cosine theta, I get this. So I can solve it. But things become a little bit complicated. If I have the same function not equal to 0, say equal to a constant k, so this is when I need to introduce what we call R formula. So R formula can be written in this way or this way. So what does R formula achieve? It basically strings or merge the two functions sine and cosine of the same angle theta into one trivial function. Alright? So let's see how we can do that. Let's focus on just one function. I'm going to expand this function. Theta minus alpha I get R cosine theta cosine alpha plus R sine theta sine alpha. Rearrange, I get this. So I have this form, noting that cosine alpha is actually a constant, sine alpha is a constant, R is also a constant. So these are not variables, not to be confused with the variable theta. Theta is my variable, my unknown. So if I compare with A sine theta plus B cos theta, I can simplify the expression. This expression is actually the coefficient of cosine theta. So the coefficient of cosine theta is B. So B equals to R cosine alpha. I call this equation 1. And A being the coefficient of sine theta is over here. So this is equal to R sine alpha. Call this equation 2. From here, I have two equations, two unknowns. My unknowns are R and alpha. R and alpha. So let's see how we can use these two equations to solve for R and alpha. By the way, A and B are known values given in the earlier question. So if I take equation 1, square it plus equation 2, square it, what I can achieve is to remove the unknown alpha. So let's see how it's done. Equation 1 square will be R square cosine square alpha plus equation 2 R square sine square alpha equals to B square plus A square. So we notice if I factorize cosine square R square out, I get cosine square alpha plus sine square alpha. And this is an identity, a triple identity that's equal to 1. So R square is equals to B square plus A square. Therefore R is equals to square root of A square plus B square. So that gives me an expression for R. Moving on, let's see how the two equations simultaneously can solve for the value of alpha. So I take equation 2 divided by equation 1, I get R sine alpha divided by R cos alpha equals to A divided by B. And we know that R and R can cancel, sine over cosine is tangent. I get A over B. Therefore alpha is equal to tangent inverse A over B. So here I have an expression for r and alpha. So let's see how this expression can be representative of my initial equation. So a sine theta plus b cos theta equals to k can be then expressed as r cosine alpha minus theta minus alpha, theta minus alpha, where r is square root of a square plus b square cosine theta minus alpha is tangent inverse of a over b. So this expression can then be used to solve for my unknown theta. Bearing in mind again, this is a known value, this is a known value, and this is a known value. So my only unknown is theta. Now on the same note, if I were to use this expression instead, I would also get a set of equation or expression that I can simplify from first principle, and here I can say that a being the coefficient of sine theta is equal to r cosine alpha here, and equation 1, and b being the coefficient of cosine theta will be equal to negative r sine alpha. Remember the negative, and this is my equation 2. So similarly, I take equation 1 square plus equation 2 square, I get rid of my alpha. I get r square is equals to a square plus b square. R is also the same expression as I had earlier. And I similarly take equation 2 divided by equation 1. I get, eliminate my r value, I get negative r sine alpha over cosine alpha r equals to b over a, and I get negative tangent alpha equals to b over a, and I can get this by taking tangent inverse of negative b over a. So I have again my expression for r and alpha. So using the same expression, plus b cos theta equals to k expressed in terms of sine I get r expression a square plus b square sine theta minus, in this case would be tangent inverse of negative b over a equals to k. So again, bearing in mind this is a constant, this is a constant, this is a constant, so we can solve for theta. So depending on whether you want it to be in terms of sine or cosine, the r formula can be easily manipulated to suit the question for ease of solving. Okay, thank you.